Position vectors are vectors that start at the origin, and they're going to be very helpful for us to use coordinates to work out vector components. I'm going to show you where it comes from and how it works, but then it comes up with a wee rule that you can use every time without having to refer back to the diagram or the origin and that sort of thing. So I've got a couple of points here, the coordinate A and the coordinate B, and I've got the origin as well. So I can take the point A and help me turn that into a vector if I use the origin to connect the two. Okay? I now have a vector here going from the origin up to A. I'm going to call that little a. Now this is a position vector, and it would be the vector 1, 2, 3, 4 along, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up. And you can see that that's been taken from the coordinates. So essentially, point A can become position vector A with x and y coordinates becoming the x and y components of the vector. So we can do that again with the coordinates of B. I can draw a vector starting from the origin going to point B, and I'm going to call that vector B. So small b is a position vector. And again, the components of that are 8 along, 5 up, so 8, 5. I can now use that to work out the components of the vector AB. So the vector AB connects A and B and moves in the direction from A to B. And I can use my position vectors to work out the components of that. So I would go along vector A and then along vector B, and that would give me the same as AB. But you'll notice that A is in the wrong direction, so I need to make that negative A for this to work. So AB is negative A plus B. Or the tidier way of writing that is B take away A. And this is the rule that we're going to use each time. So if I want to work out the position, or I want to work out the vector AB, and I've only got the coordinates, I'm going to take the position vector of the second point and subtract the position vector of the first point. So this is our rule. So in this case, the vector would be 8, 5, take away 4, 11. So that would be 4, negative 6. And I can do some examples that don't require a picture. Okay, I want to work out the vector AB. So that's going to give me B take away A. So I'm going to take the coordinates of B and write them as components. So x on the top, y on the bottom. And then A is negative 3, 4, x is on the top, y is on the bottom. So that's going to give me the vector 5, and 0 take away 4 is negative 4. Okay? If I want to work out the vector BC, I'm going to do C take away B. Alright, so I can turn the coordinates of C into components, negative 1, and B would be 2, 0. So 6 take away 2 is 4, and negative 2 take away 1 is negative 1. Lastly, if I want to work out the components of CA, I would be doing A take away C. So my components of position vector A are negative 3, 4, and my components of position vector C are 6, negative 1. Negative 3 take away 6 is negative 9, and then 4 take away negative 1 is 5. I'll do a 3-dimensional example as well. So if A is 1, 4, negative 2, and B is 0, 5, negative 7, what is AB. So that would be take away A, and I can turn my coordinates into components 0, 5, -7. And again, my coordinates of A would become components 1, 4, -2. So 0 take away 1 is -1, 5 take away 4 is 1, and that will become -7 add 2, which is -5. So it works in 3 dimensions as well.